Okay, guys, in this video, we are going to take a look at applications of the dot product to find work of a force. So there will be two different formulas that you're going to be using to find work of a force. Okay, and that's actually the two equivalent representations for the dot product. Depending on what you are given, you're going to use either one or the other one. So here's the first formula. So to find work of a force, you're going to take the force if it's given to you using components, so in vector format, and you're going to dot it with the displacement. So we'll call it D. So what is that? So imagine that you are moving, and then this is some constant force is moving a particle from point P to point Q. Okay, so that this line segment, right, from here to here, that's going to be your PQ. This is going to be D. Okay, and the force is a constant force. So to find the work, we're going to just find the dot product of F and then PQ or D. So a typical question would say something like, okay, so let's say a force is moving an object, and maybe the force has components 1, -1, 3, and it's moving it from one point, let's say P, which is -1 to 5, to Q, I don't know, 1, 0, 2. So find the work. So what are you going to need to do? Well, first you're going to need to find that displacement vector, so vector PQ, which you're going to find by, remember, subtracting the coordinates of P from coordinates of Q. So start with Q and subtract P from it. And 2 minus 5, okay. So what will that be? That's going to be 2, -2, -3. Once you find that displacement vector, you're just going to dot them, F and PQ, and that's going to be the answer. So you're going to take 1 times 2 plus -1 times -2 plus 3 times -3. And that's going to be 2 plus 2 is 4 minus 9. So that's -5. And that's work. Okay, that's work. Now, a common misconception is that the work cannot be negative. That is actually incorrect. Number one, work is a number, not a vector. That is correct. But also it could be negative. And that is if the force is actually, it depends on the angle between the force and the displacement vector. If it's obtuse, then actually you will get a negative work. It is perfectly fine. Never remove a negative. It's not like it's volume or area where it cannot be negative. It can, okay? So that is if they gave you the force and then the initial and terminal point. But in this specific question, you get a different format for the dot product. So there is another format for the dot product, and we always use one or the other. The second one is, this is going to be magnitude of F multiplied by magnitude of D, which is the displacement vector, multiplied by cosine of the angle between them. So it just depends on what they give you. In my case, so this is a cart that somebody is pulling. The angle is 60 degrees between the way it's going and the angle, right? How, you're pulling it by some rope or whatever. And it's going to move 23 feet across the ground. What's the work? Well, you're going to use this part, right? Because you don't want to make it a vector. That's going to be too much work. But this one, everything is already given. So you're given the force, which is 35 pounds. So you're going to just put that 35 right there. Then you're going to have the displacement, which is 23 feet. Now, here you have to be very careful in terms of the units of measurement, because work is measured either in foot-pounds or joules. So foot-pounds, if in this case force is measured in pounds, and the displacement should be in feet. If the displacement is in inches, you would have to convert it to feet by dividing by 12. Okay, so you got to be careful. If it says 23 inches, so that would have been actually 23 over 12. Okay, same thing in the other units of measurement. Sometimes they say, okay, the force is, let's say, 35 Newton, and let's say it's moving, I don't know, 23 centimeters. So you have to convert the centimeters to meters by dividing by 100. So you have to be careful of the units. But in this case, you don't need anything because it's pound and feet. And then cosine of the angle between them is what you get. Okay, so that's just 35 times 23 times cosine 60. Now, cosine 60 degrees, I believe, is 1/2. If you do not believe me, just put cosine 60. Just make sure that your calculator is in degrees, and you can see it's 1/2. So this is going to be 35 multiplied by 23 multiplied by 1/2. So looks to me like that's 402.5.